Hello everyone, thank you very much and welcome back to today's class. And in today's class, we'll be talking about load separation in a different form. We've talked about load separation before in our previous videos, where we talked about how to do separation for just a small system, um, majorly a single phase system. Now, in this class, we'll be talking about how to do separation for a bigger house, for instance, a duplex, because the way it is being wired is a little bit quite different from how bungalows and other kinds of apartments are wired. And so you need to understand a bit more of how the wiring is done before you can get to know how exactly to do separation for a duplex building. And before I start, I just want to say a very big thank you to every one of you that engaged on my content. The previous year, 2025, this is my first teaching video or tutorial video for 2026. And I hope that we're able to do more exploits this year. And thank you very much and keep watching and keep liking and keep sharing. And also let me know where exactly you're watching this video from. Just comment your name and your location in the comment section. So let's continue. Now, talk about load separation. Now, we already know what load separation is. I'm going to tag the previous video I did about load separation so that you understand it from the beginning. In case it's the first time you're coming across my video. Now, you have an inverter. The inverter is rated, let's say, about 5 kVA. But you have loads that are heavier than the inverter. Let's say the total load you have in your house is above 5,000 watts. Let's say about 8,000 watts of load. Then your inverter is about 5 kVA, or let's just say 4,800 watts. Now, for you to be able to connect the inverter's output to the loads in your house or your apartment, you have to be able to separate some loads, essential loads, from non-essential loads. Now, it is not advisable to connect directly from the inverter to all the loads in your house, because if you are currently using the power from the grid and you're not around and somebody mistakenly change over from the grid to the inverter and all these loads are on, or let's say majority of these loads are on, is going to have a very big toll on the inverter because it's just 4,800 watts. So that's why you see overload and all that. Okay. Now, so you know you have 8,000 watts and you have 4,000 on your inverter. You're even supposed to load it up to 4,800 watts. You're supposed to load it to highest 70% of the entire capacity of the inverter. So you need to now look for a way to divide the loads, separate some loads, essential loads from non-essential loads. So instead of you connecting everything from the inverter to all the loads in your house, so you'll not be able to cut out some loads such that the inverter will only supply power to the essential load. Now, the essential load is probably the loads that you want to power with the inverter, even when there's no grid supply. Now, you can talk about the lights, lighting points, fans, TVs, and so on and so forth. Those are essential loads. Non-essential loads such as the microwave, the water heaters, ACs, and so on and so forth. Non-essential load. It depends on how you use power in your house. That would determine what exactly are your essential loads and your non-essential loads. It also depends on the size of your setup. Your size of setup can conveniently power 5 ACs at a time, then your essential loads will be a bit more different from what I've stated before. So let's leave that. Now that's separation for you. So when you connect this to your essential loads, probably we have about 6,000 watts here. Then you have about 2,000 watts here. So you can see that it's within the range of the 4,800 watts of the inverter. And so this is safe for connection. So that is what separation is all about. In the previous video, we talked about separation for single phase wiring. And in today's video, we are talking about separation for three phase wiring. Now, this is a duplex. We are using a duplex as a case study. In the duplex apartments, how is the duplex wired? Now we have the top floor, then we have the bottom floor. Now we have two DBs, two distribution boards. This is the first DB and this is the second DB. Then we have the powerhouse. The powerhouse is mostly situated at the securities office or something like that. Now, from the powerhouse, you have the load wire that feeds the building directly from the powerhouse to either the bottom part of the duplex, then it links to the top part of the duplex. Now, it goes straight to the DB. The wire that comes from power is either from your meter or from your switchboard or anyone. It comes from the powerhouse straight to the DB. Now, it's important for you to do three-phase wiring because for houses like this, we normally have a lot of loads. You can have up to about 6 ACs. So if you use just a single 10 wire to run the load from the powerhouse and decide to loop it to get single phase wiring, then it's going to burn out. So it's advisable to use three-phase wiring. That's why three-phase wiring is used. Now, when you check, you see that it's always like this. You have one wire goes to the first phase, then the other wire goes to the second phase, then the third wire goes to the last phase. This three-phase wire, and then we have your neutral. The neutral doesn't have any phase. It goes straight to the DB of the neutral, and it also links to the other one in the other flat upstairs. So this is neutral. This is neutral. Then these are the three phases, the live wires. Now, it doesn't really matter whether the source of these wires, whether it's in single phase or in three phase. You can have three phase wiring from the pole directly to a three phase meter, and from three phase meter you take the three phase output, the red, yellow, and blue, directly to this DB. Or you can also merge the three phase when it gets to the fuse section. Because if wire comes from your pole, something like this, it goes straight to the fuse. It goes straight to the fuse. Then the fourth wire is a neutral. The next one goes to your meter directly. This is a meter. Now, this is a neutral, goes to your meter directly. You can either convert this three phase to single phase and also get a three phase output from your three phase meter and send to the house. Or you can also leave it at three phase and also send the three phase to the house. But most of the houses in Nigeria, or let's say in the location where I live, what they do, they take the three phase separately from the pole, they take it to the fuse. At this section, when it gets to the fuse, they loop it, they convert to single phase. So when they convert it to single phase, they will feed the input of the meter as three phase, just like this. So at this point, you will only use one fuse. So when this one is fused, it supplies power to this point, this and this. So this is the arrow, this is the Y, and this is the B. So when the meter takes input as the three phase, it gives output as three phase, although it's just one phase already. But then it's important so that they can use three wires to run the load from the switch box to the DB downstairs and upstairs. So when it gets here, we have three phase. So the three phase comes here like this and goes to the DB straight up. Okay, then we have your neutral. Neutral doesn't change. Neutral goes like that every time. Neutral follows all the way down to the board, straight up. Okay, now when you go to any duplex apartments, you always find two DBs, one up and one down. And there's always a point of interconnection, a point of connection where the DB upstairs and the one downstairs connect. Now, it's in two ways. It's either the one downstairs is looped to the one upstairs. This is the input for the DB upstairs. So you can either loop from here to like this, and like this, or because if the positions of the DB is not aligned in such a way that you can use a single pipe to draw the wires or the cables directly from bottom to the top. So you can either just look for a place or an adaptable bus close to where the first DB is. Then you route the wires to that adaptable bus or a bus bar where you have something like this. A bus bar, one, two, three, four. So the first phase comes to this part, the other one comes here, the three phase comes here, that's ROYB. Then we have the neutral. Then again, this is the one that comes from the switch bus to the adaptable bus. Then again, the DB downstairs goes straight to this bus bar, also connects here. 3, 4. Then also the DB upstairs connects here again. So we have 3 connections. So this is the point of interconnection where the up DB and the down DB connect together. So to get power from this single source, from this single meter. You get the point? So that is how a duplex is connected. And when you want to do separation for this kind of building, you need a little bit more understanding of how these things are done. And it's quite different from a single phase, because single phase is just direct and straightforward. So for a 3-phase, when you go to any house, first of all, open the DB and observe if it's a single wire or if we have 3 wires going to the DB as inputs. If it's looped from there to the other side, it's very easy for you. It's going to be easy. But if it's not looped, you need to find the adaptable bus where they connected the up and the down DB together. Let's assume that they didn't loop it from the bottom to the top. So we have the input from this main switch at the security house. It comes here directly. So this is neutral. Well, let me connect. Okay, neutral comes here. Then this is B. This is Y. Then this arrow comes here. Okay, so this is neutral. Now the same thing, this one also does the same thing. Comes here like this, connects. This one connects. Don't mind my wiring. Connect. Then this one connects as well. So when you find these points, then your work is about 50% done. Now, how is a duplex wired for separation? Okay, I want you to take a look at this diagram. It might be confusing, but then it's straightforward, very easy and simple to understand and to comprehend. Now, this is the changeover at the security post. You might likely have a 3-phase changeover there where you loop the generator output, because the generator is single phase. So this generator, then this is the one coming from the meter, the 3-phase meter, ROYB and neutral. Remember, it was a single phase that was converted into 3-phase. So this is ROYB neutral. Just assume it's 3-phase, it wasn't converted. Just forget about the conversion. Now we have ROYB and neutral. Now it goes to the bus bar. First of all, arrow goes to arrow. This is red. Y goes to Y, and B goes to B. The neutral connects to the neutral. This is up DB. This wire goes to the up DB. Then this one goes to the down DB as well. So this is the buzzer where the both DBs were connected. Don't worry, I'm going to show a video after this theoretical demonstration. I'll show you a video how I did the practical separation for case study like this. I'll show you the video. I just want to give you diagrams so that you understand a bit more about how it is done. Then, okay. Now let's go. We have the up DB and the down DB. Now, this DB is just the up DB. Forget about the down DB. Whatever is happening at down DB is the same as happening at the up DB. So forget about the down DB. I'm going to use one as a case study to explain what is happening here. Now, this L1, this arrow phase arrow. Now, when we're talking about DB connections, we talk about it in terms of lines, line 1, line 2, and line 3. So we have line 1, line 2, line 3. Now the 3 10mm cables from this bus bar go straight to the DB at line 1, line 2, and line 3. Now, when you want to do separation, you need to, first of all, identify the lines. If you want to use line 1 as your inverter load, you're going to have to choose one line that you're going to feed your inverter loads to, because it's a single phase inverter. If it's a 3-phase inverter, it's a different thing entirely. You just have to feed it separately to the three lines. You don't have to change anything. But since it's a single phase inverter, we have to choose a particular line where our output from the inverter will be connected to. This is how your DB is wired. Now your DB, for instance, this is an 18-way DB. We have 9 breakers on the left side, 9 breakers on the right hand side. It goes like this. When you start to count, you start counting from line one, from the topmost part. 1, 2, 3, 1, 2, 3, 1, 2, 3. So we have 6 circuits per line. So line one has 6, line two has 6, and line three has 6. That's 3 times 6, 18. The 18-way DB. So this is connected. Now, this line is connected to this one. But if you disconnect the output from here, these lines, all the line one, they will not have power. You can see the way I did the drawing. Just check. All the line one is connected together. It doesn't have any connection with line two and line three. Okay, so that is how it is done. Now, this is your inverter. It supplies the output to a single phase changeover. Then the output from the changeover goes to line one. Then the neutral goes to the DB. The neutral can link. It doesn't matter. So, but the output goes to line one. Now, before you connect your output to line one, you need to make sure you disconnect line one from the changeover switch. Because when you connect your output to line one at this point and your inverter is on and there's supply from the grid from here, then we are going to have a short circuit of different power sources, grid and inverter together, and that's going to get disastrous. Okay, so either your meter or inverter will collect this, the weaker of the two will collect. All right, so we have the arrow. Now you need to make sure you trace. Before you trace this one, make sure you also trace to check the exact line, because people who do wiring, they don't really pay attention to these things. So if they use a particular cable for L1 here, when you go down, you find out that that cable is actually L3 downstairs. So you need to make sure it is well aligned. L1 up is L1 down. So when you do that, trace to see that you get the particular spots where this line one is connected to on the changeover. So when you trace to this side, this is line one on the bus bar. From the bus bar, you also trace. So this is line one arrow. So I'm going to disconnect the phase from this point. So there will not be any connection from this side. So this wire from the bus bar will remain idle at the security post. Okay, so leave it like that. So this one, there will not be any connection for arrow. Okay, this is B. Okay, this is arrow now. All right, so B is connected. So I'm talking about this one. So this is the arrow now. It has been isolated. Okay, so when you isolate the arrow, then you can now safely connect your inverter to the DB for line one. So all the loads connected to line one will light up, but the loads connected to line two and line three, there will be no power supply on those loads. All right. Then how do you now get your input to the inverter? Your input to the inverter comes from any of these two lines, because either line two or line three will get supply from the grid. So you can take from any of these two lines, or you just tap directly from here. But we take from these two lines and you connect to the input side of the inverter. If the loads is too much, it's going to trip the breaker off, because you're taking from the breaker. So you take from this point, either line two or line three, then loop it to the inverter's changeover on top for charging. Then the same thing, take a neutral, also loop it there. Then from here, you can feed the inverter's input. This input of the inverter, this live and this neutral. The same thing for neutral. Take neutral from here and feed it here for inputs. Then when the inverter is supplying the house, it will only supply loads in line one. And when you want to do separation, you need to remove the loads that you don't want on the inverter from line one. If you don't want ACs on the inverter, remove all the ACs from line one. Just have to keep checking, remove the wires, then check to see the loads that are on, then you connect to line one. The ones that you don't want to be on, put it on line two or line three, share the loads properly. The ones you want to be on the inverter, put on line one. That's as simple as that. Then we have the wire, the arrow phase idle here. It's coming directly from the inverter's output. So you can also take this one as a supply to the security house in case the owner wants you to power the security house as well. And from there, they can switch on the surrounding boards from the security house. So from here, you can also power that of the security house. So you just have to isolate the wiring from either of the phases where the security house was connected to, then connect the red or the live to this one from the on the red phase. Then you also tap the neutral from here. So this one goes to the security house. Security to provide power for the security. So that's how you do three-phase connection and three-phase separation. So I hope you understand this illustration. So if there's any question you have at this point, just put in the comment section. We'll answer you. And again, after this video, I'm going to show you the practical demonstration so that you understand it a bit better. Yeah. Okay. So that's pretty it. There's nothing much to do. There's nothing much. So this is how you do your connections for your solar systems for a single phase. I'm also going to do a separate video for duplexes that are connected in single phase. So that is also different. I'm also going to do a video for a case where they used a three-phase generator, but the wiring in the house from the grid is a single phase. So if you want to connect the inverter at that point, you also need a three-phase changeover as well in that case. Okay, thank you very much, and please watch the other video attached to this one. Thank you. I'll see you soon. Okay, so I quickly want to show you something that's very important for inverter and battery connections. How to connect it to your main building and do separation. Now, you can see that for this house, it's a duplex. We have two consumer units in the house or distribution box. So we have one up here. They also have another one down to control the loads at that section. Then we have this one up here to control some other loads. We have a lot of rooms here. We also have rooms downstairs. Now, if you look closely, you see that it's a three-phase wiring. So we have three wires going into the input of the MCCB. You get? Now, normally we are supposed to have just one wire going into this stuff, then it will be looped as a single phase wiring. But this one it's a three-phase wiring. And so that three phase is being splitted across these breakers up there. So we have line 1, line 2, and line 3. So if you are familiar with electrical installations, you understand what I'm talking about. So we have line 1, line 2, line 3. So you are starting from the topmost parts is line 1. So after counting line 1, 2, 3, then 1 starts again. So we have 18 in total. Okay, so that's not, we are going to get there soon. But for now, I came to this site and I discovered that it's a three-phase wiring, and I initially planned that I'm going to mount the inverter system up here, not downstairs. Okay, so now when I checked downstairs, I saw that the input to the MCCB is also three-phase. And normally, in some cases, you see that the connection from downstairs also loops from the MCCB to the one upstairs, because there's supposed to be a point where the looping will be done. So you need to get that point. I saw that the looping was not done downstairs. It wasn't done here. So I had to climb up into the roof and I had to trace it to a particular spot on the building. So let me show you where it was done. So they took the wires to one adaptable bus outside and they did the looping there. So I'll show you what they did. Then I'll also show you the entire architecture of this wiring. So in case you have a job and come to you see something like this in the house, you'll be able to know what to do, what exactly to do. Now we have the three phase here. This is the DB downstairs. We have three phase going into this one too as well. Okay, and so let me show you where it was looped. Now right here, you can see that this is where the looping was done. It's very clear. Now it's a three-phase wiring, three-phase and neutral. Now the neutral is always black, coming from the fuse outside, the fuse in the security house. So the neutral is black. Then we have the red, yellow, and blue is an armored cable. So you have ROYB. So the arrow, this is the arrow phase, the red phase. You can see we have two 10 mm cables tapping from this red phase. So one of these cables goes to the DB downstairs, then the other one goes to DB upstairs. The same thing for this one. This is blue. We have two red. One goes downstairs, the other one goes upstairs. Also for this one as well. So you can see that I think they had to indicate with a black tape the one that goes downstairs. I think the one that goes downstairs was indicated with this black tape. then why the other one is the one upstairs in case you want to do maintenance. Now, when you get this I think this is 8 cable, yeah, 4 for 18. Now, when you get this, you have little or no problems because actually, initially, the customer told us to separate some loads from because we have up to about 9 ACs in this house, and it's a 5 kilowatt hour lithium battery. There's no way you're able to use that 5 kilowatt hour lithium battery to power the whole ACs. We have 7 ACs up to 9 ACs, and we have a 6 kV inverter. At most, I said they should use one AC. So I'm also going to do separation for the AC. Then what I plan to do is this. I plan to use one of the phases right here for the inverter load. I'm going to use one of the phases, either the red, the blue, or the yellow phase. Now, when I take one of the phase, I'm also going to make sure I verify up there to know if it is same for up and down. Then from there, I'm going to take it to phase one. So I'll use phase one or L1 to get the inverter load. So any load that is connected to L1, inverter will supply power to that circuit or to that sub circuit for L1. Okay, so from there I can do the separation and I can add the AC that is required for me to add the one AC to L1. Then the remaining ACs connected to L1 go for up and down. I will disconnect them and I will connect them to L2 equally. So that's how to do separation for 3 phase for a house that has 3 phase wiring. It's very simple and very easy. You don't have to start getting another DB or a breaker box for that. You don't have to start joining cables all the time. You just have to unplug the ACs connected to the L1 because we have 3 up to 6 circuits for L1. So we have 6 for L1, 6 for L2, and 6 for L3. Altogether 18 circuits. So we connect the L1 to the any of the 6 circuits, all the loads, the essentially like the lights, the fans, and the one AC. Then the many ACs and other cooker units, what's it called? Will be connected to L2 and L3. Now let me show you where this cable is coming from. Now it's coming from the security posts. Let me show you. Come with the plier. Well, this place is quite tight, but I just hope you're able to follow me. Now, this is security post. The Everything starts from here. We have the fuse. It's a single phase wiring, but they had to use 3 10 cables and 3 phase in order for the load not to be too much on one wire, on one 10 cable. So they had to use 3 cables to do 3 phase on DB side. But on this very side, you see it's just one fuse that's connected. So it's a single phase. Now, the output goes to this meter. You get the point? Then you see this is the input. Then the output from the meter goes to the changeover switch here. So, and from the changeover switch, we have the red, yellow, and the blue phase. Okay, so this is yellow, this is red, this is blue. Now, initially, when I came here, I discovered that we have some tenant houses, boys' quarter over there. When they switched on generator and they took this generator side, it supplied power to the entire building, both the tenant house. So I was surprised because of how they did the wiring. And the owner told me to disconnect the solar from the boys' quarter and add the security house to the boys' quarter. So at first I was confused on how I'm going to do it. I thought I would fly a wire directly from the main building to this side. But when I saw that it's 3 phase wiring and it started from here, so I needed not to do that. So all I need to do now is to indicate if I'm going to use the red phase as my inverter load. The red phase is right here. I'll first of all have to disconnect it from this changeover so that when there's light from either near power generator, it's not going to jam. So when I disconnect the red phase completely, I'm going to cut it out from here. So that's going to be my inverter phase. So we now have inverter phase, phase one and phase two, instead of phase one, phase two, and phase three. So that's my inverter phase. We have power connected to this. If I connect power from the inverter side in there, it connects the top DB, the bottom DB, and it also connects to this point, the end in the termination of this wire. So I'm going to connect from the termination of this wire to the live wire that took power to this security building. So I think it's this wire from here. Okay, so we have this as the red, then we have this connected to, okay, this is neutral. So this is neutral. I'm going to leave the neutral the way it is. Then the other one is the live. I'm going to pull it out for me and connect to this one. as my inverter load for the security house. In that case, the security house is going to have power. Then I think the other loads connected goes to the boys' quarter, so I don't need to disconnect it from this changeover because I don't want the boys' quarters to be connected to the inverter. So I'll only disconnect the security house from here and I'll connect it to this one. Then for me to get input to charge the inverter, I'm going to tap from either of the other phases, L2 or L3. So when I tap from L2 and L2, send it to the changeover inside. Then whenever there's light and did the changeover there, it's going to reflect across board. Okay? So that's what I'm going to do. So it means this changeover is not general changeover anymore. When you do this one, it enables you to get power to only L2 and L3. But if this one is connected to L1 and you don't change over to L1 on the inverter side, then you're going to get power from grid or generator. So if you want to get power from grid and generator, make sure over there on the inverter side is switched to grid/generator. So it connects from L2 or L3, then it gives power to this one as well. So if you want to use inverter, you take it to the inverter sends output to L1. Okay, so I guess you understand the whole scenario. So let me go inside and do the separation for the AC. So what I'm going to do, I'm just going to check. I need just one AC upstairs to be on the inverter. So I'm going to check to know the exact wire, the exact cable that feeds the AC from the DB. So I'm going to remove it from either, if it's on L2 or L3, I'm moving from L2 or L3, and I'll take it to L1. If it's on L1 already, I'm going to leave it the way it is. Then I'll remove every other ACs from L1 and share equally for L2 and L3. So let's do that. So I'll remove the wire. So it's here. I think this one is for the alarm to know whether there's lights or not. It's not working anymore. Let me just connect it. In case you want to replace it, it's just going to be a plug and play. So we are situating and we discover that the first wire here on L1 is actually the third wire on the other DB as L1. So all we are going to do, we are going to swap the L3 for L1 on the other DB. Okay. So right away, let's do that right now. Okay. So you go down there. Come with your screwdrivers, flat or star. So this is flat. Then this star. So we swap it to L1. So let's know what we are doing. In case we want to do separation down there, we are not going to start racking our brains to think in reverse. You get the point? So what is applicable up there is also going to be applicable here. All right, so just switch it. Let me see. Hold it. If I can. I can't. Okay, hold it. You can, actually. Move it. Take to L1 there. Push it in. Okay. I'll look. Same here. Push it in. Okay. Look. So I'll do the same thing. Then we'll go to the security post to check which of the phase, if it's red, yellow, or blue phase. So go with your bulb. Take your communication device. So you tell us. Okay. I'll take this one. Let me take the other one. Can you hear me? Can you hear me?
Yeah, I can hear you.
All right. Confirm the phase. Confirm the phase. confirming now. I just confirmed. The one you remove, that's the line. One you remove here, that's the one that has power in it. Copy, correct. Sharp. So we are done with this first step. The next thing is the separation. So we already know that these are low, these are inverter loads, phase one, L1. So we are going to separate the ACs from L1 to L2 and L3. So let's do that right now. On, Abi. Look at the air you said. Once it off, let me know. Off, 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 off. This one goes off for now. Off. Uh-uh. I bet off and for the, yeah, yeah. All right, that video didn't end well because it took us a lot of time to be able to separate everything, and it was already dark, so we could not do the full video for the separation. But like I said, it's just simple. Every other load you have connected on L2 and L3, essential loads according to you, just disconnect them. Just disconnect them at this point, and we connect to L1. Then every other load that are non-essential loads connected to L1, disconnect them and connect them to either L2 or L3. So that's how you do it. Do the same thing for the down DB and you're covered. But the thing is, one of the challenges that you can face in such when doing separation for such a system, especially when you have, especially for the down DB, because it's a decking apartment. Now, in a situation whereby the wiring is not properly done, for instance, there are some persons that do wiring. For instance, this is an AC socket. Then below you have a TV socket or a normal 15 amp socket. If when doing wiring, you're supposed to use two separate cables, two red cables. That's either a 4 cable or a 2.5 cable. So when you use two separate cables, one terminates at the point where you have to connect your AC. Then while the other one terminates at the TV side, the TV socket. Okay? Then they will both share a common neutral. This is how wiring is supposed to be done. They will share a common neutral. This is neutral. Then this is live L2, L1, L2. So you can have these wires, can now locate these wires separately on the board. Even if they were connected together before, when you are doing separation and you lose one, discover that either the AC socket or the TV socket is that one you lose. So if you need the TV socket to be on, you just put it on L1, then leave the AC socket on L2. But in a situation whereby they use one wire to connect both the AC and the TV socket, and you don't want this AC to be on for the inverter, if you disconnect the AC from L1 and put it on L2, it means you have also disconnected the socket from L1 from the inverter supply, and this socket is supposed to be an essential load. So this is just an advice to our installers or electricians. When doing wiring, make sure you use separate cables. Where you have a line like this coming down, and you have AC here, and you have a TV socket here or a normal socket, use separate cables, use separate red cables, connect them. Then they can share a common neutral. In case of things like this, when you want to do separation, it's not difficult because for you to be able to run this one, you either have to start doing surface connection of another cable straight to this socket, so you can connect that surface that cable to L1, or you either just have to put connect both the AC and the socket on the L1. Then you now have to start controlling the AC manually. So in a situation whereby you did separation and you're still controlling, you're still being mindful of the loads that are on, then it defeats the purpose of the separation in the first place. So I just want to bring that to your notice, and just that's the end of the class. Nothing else to talk about. Just let me know if you have any questions. Put them in the comment section. Please like this video, share this video, and also let me know where you're watching the video from. Thank you very much, and I'll see you again in my next videos. Bye.